All right. Uh, I wanted to make a video, and yes, I'm talking to an empty classroom, so this could be entertaining. A video that is shorter than the 1 hour video about the mole and conversion factors for those of you who are writing tests and don't necessarily want to watch that entire hour video. Again, if you want more details, by all means, go and check out that hour-long video. All right, jump ahead to places. But I just want to do a summary lesson, so maybe you can get it figured out with just a short lesson. So this is about something called the mole. All right, I'm going to explain to you what the mole is, and it's also about something called conversion factors. All right. So the mole is a special thing that we use to measure atoms and ions and all those things called entities. All right. Conversion factors. That's a mathematical trick that we use in order to do our calculations. All right. So in order for you to understand what we mean by this thing called the mole, all right, I'm going to compare it to something that you already know. So I'm going to break my page in half here, my board in half. And over here, I want to talk about something that you know how to count, and that's eggs, all right? So let's say eggs are small, all right? They're small in that when you go and purchase eggs, you don't buy one egg at a time. That makes no sense. So what do? We group eggs. We group eggs together. And so what do? We put eggs, all right, into dozens, all right? So we put a group of eggs together to make them more convenient to deal with, all right? And essentially we can say 1 dozen is equal to 12 eggs, right? So we can define what a dozen is. We do the exact same thing with atoms and molecules and ions and formula units, all those things we called entities. So for the atom side of it, atoms, and essentially we're talking about all those things called entities, are very small. So it's definitely not convenient to talk about atoms or entities on their own individuals. So we put them into groups. Just like we put eggs into groups, into dozens, we put atoms and entities into groups, all right? And we put them into a group called a mole, all right? So we put entities into what we call a mole, or moles. Put an S on the end of it, just like we've got an S on the end of the dozens. So we put them into moles. Now the word mole probably comes from the word molecule that they made short because they were creating kind of a new thing in which to count things. Dozens for dealing with things like eggs, and moles if we're dealing with little tiny things like atoms, molecules, and entities. And it turns out that 1 mole is equal to, and notice how I dropped the E off of it, just like I created a short form for dozens, DOZ, this is the short form for mole, all right? And so 1 mole is equal to 6.02 times 10 to the 23 entities, all right? Notice I just put ent. That represents, again, atoms, molecules, ions, formula units, all those things that we deal with, all right? So notice this is a really big number, times 10 to the 23. It's got 3 significant digits. We actually, as chemists, know it to many more significant digits, but 3 is good enough for us at this point. And notice it's got scientific notation times 10 to the 23, which means this number has 23 zeros on the back end, so it's huge. But it has to be huge. You'll notice it's kind of a funny number. It's not like 1 times 10 to the 23. So this is a special number, and we will learn in the future why we choose that number and why it's so special. Okay, so once we know, oh, by the way, this number has a special name, all right? This number has a special name. We call it NA, all right? And I'm hoping we can see it. I'm taking a look. Yep, NA. NA is the number 6.02 times 10 to the 23 entities per mole, and we call this Avogadro's number, all right? And that's named after the scientist who first did experiments that allowed chemists to determine what this magic number is. He never actually determined the number himself, but in the end, this number was determined using stuff that he had discovered. All right. So Na is a short form for writing that number. Okay. So it's a really big number. And how do we use this big number? All right. Let's do some calculations with some dozens first, something that we understand. So let's say I knew that we had so many eggs. Let's say you're an egg farmer and you've got so many eggs and you've got to report to the company how many dozens you have, all right? And so let's say we've got lots of eggs, 3,672 eggs, and the question is, how many dozens is that? Now, most of you know how to do this already. You've done calculations like this for years, probably even in elementary school. Okay, I know there's 12 eggs in each dozen, and away I go, I calculate. When it comes to the mole, you haven't used that before, so it could be a little confusing. So let's come up with a way that we can calculate both. What we do is we create something called a conversion factor, all right? Conversion factors can come from anything that is an equality. 1 dozen equals 12 eggs. So one possible conversion factor, and by the way, a conversion factor is a fraction. So that's that middle line for the fraction. And I create it by taking the numbers in the equality. Eggs. I want to cancel out eggs. So I'm going to take the 12 eggs and put it down there. And that's equal to 1 dozen. All right. So what did I do here? I created a little fraction out of this equality, and because my starting unit is eggs, I want to cancel out that starting unit, so I put it on the bottom of the fraction, and I put the final unit I want it to become on the top. This is just like if you were doing some math. Let's say you had 2a, and you multiplied that by some fraction. Oh, and you can hardly see the 2a, so I'm going to slide it over. There we go. Let's say you had 2a, and you multiplied it by a fraction that said 3b over 5a. Oops, that's a d. 5a. Just like in math, you can cancel out the a's. All right? Because 1 is in the numerator of this number. It doesn't have a denominator. Notice it doesn't have a line. So it's in the numerator, that's in the denominator, we can cancel it out. We can do the same thing with units. So, because I had eggs here at the beginning, I wanted a conversion factor that put eggs at the bottom. I know that 12 eggs is equal to 1 dozen. I can cancel out eggs. I'm now going to get my calculator because I have no helpers. 3,672 divided by 12 equals 306 dozen, all right? So I can take my eggs and figure out how many dozen there are using this conversion factor. If I wanted to go from dozens to eggs, all right, I can do the same but the opposite. Let's say that some store had an excess of 29.2 dozen eggs, and I know you might be saying 0.2 dozen? Like, what the heck, 0.2 dozen? That's kind of silly. But let's say that's the case. And we wanted to figure out how many eggs there are. Again, I'm going to create a conversion factor from the equality. This time, I want to cancel out dozens, so I want it to be on the bottom. So for every 1 dozen, there are 12 eggs, and the dozens cancel out. Now you'll notice this 12 is on the top. Any numbers that are on the top of the fractions, we will multiply, and any numbers that are on the bottom of the fractions, we will divide. So technically for this one, I will put 29.2 times 12 divided by 1. I could do that, but when you divide something by 1, it doesn't do anything mathematically, so I'm just going to leave it as 29.2 times 12 equals 350.4, 350.4 eggs. Now you might think that's kind of silly, how can you have 0.4 eggs? But we now can use our significant digits. If we know this to 3 significant digits, That's a whole number, all right? We know that for certain, so it's got many significant digits. If I round that to 3 significant digits, 350 eggs, all right? I don't know if you can see that at the bottom. Yeah, you can right there, 350 eggs. So we can create a conversion factor. I can do the exact same thing. I'm gonna slide this over here so I'm in the middle with the mole. Let's say I wanted to, I'm just taking a look at my note. Let's say I had some entities and I wanted to figure out how many moles I have. Well, we use this number. We use Avogadro's number. This is a little map that kind of helps me think about what I'm doing. Whenever I want to go from entities to moles, I need to use Avogadro's number. So if I had 6.97 times 10 to the 24 entities, atoms of carbon. All right, atoms of carbon. I'm going to create a conversion factor. Let me get this out of the way. Here's our equality, moles and entities. Atoms, you need to realize that atoms are entities. So I need my entities number at the bottom. 6.02 times 10 to the 23 entities per 1 mole. Entities have canceled away. Atoms and entities are the same thing. And look at the unit that I'm left with, moles. I would put it off to the side, but I'm out of room. Equals my unit. The only thing that's left is moles of carbon. Moles of carbon. Now I need to do the calculation. Okay. This calculation is special because I need scientific notation. Whenever you do scientific notation, you're going to use a button here, the EXP button, if it's on a sharp, and or the EE button, there it is right there, EE button, if you're on Texas Instruments. So I'm going to press 6.97. Then I'm not going to press times, and I'm not going to press 10, but I'm going to press the EXP button. On this calculator, it puts a little E, right? That little E stands for times 10 to the. Now I'm going to put 24. And there it is. All right? Now, times 1. I don't really have to times 1 because it doesn't do anything. Divided by, all right? There it is there, divided by. Then I do the same. 6.02 EXP 23, all right, and equals. All right, you can see there 11.578, blah, 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 blah. And I've lost my chalk. There it is. 11.578. Just 1 second. I am being interrupted. Okay, we're back in business. So 11.58 moles. Let's take a look at our significant digits. This has 3 significant digits, all right? That's the way that number was measured. This also has 3 significant digits, 6.02. This 1 is a whole number. We don't even count those. It's perfect. It's exactly 1. So I need to round this to 3 significant digits. So the proper way to do that is 11.6 moles of carbon, and there's the final answer for that. All right? Okay? So that's how we can go from entities to moles. Let's talk about going back the other way. I'm just going to turn things here a little bit. So what if we wanted to start with moles and go to entities? Whenever you go from moles to entities or entities to moles, you need that big number, that Avogadro's number. So let's say that we're starting with 0.00952, well, we'll just go 95. 2 significant digits, moles. Let's say we've measured that. And let's make it moles of water, all right? Moles of water. How many molecules are in there? The entities. So this time I need to go from moles to entities. Again, I'm going to create my conversion factor. My conversion factor is going to come from this number, all right? Moles and entities. This time, I want to get rid of moles. So moles has to go on the bottom. for every 1 mole, all right, there it is on the bottom, that's going to cancel that out. There are 6.02 times 10 to the 23 entities. 6.02 times 10 to the 23 entities, and in this case, it's molecules. Again with the calculator, so 0.0095 times, because you can see there, it's times 6.02 EXP or EE if it's on the other type of a calculator, 23. I could press divided by 1, but there's no need to, it doesn't do anything. Divided by 1. Oh, I just said there's no need to and I did it. Doesn't hurt. Equals, all right? And I get 5.719 times 10 to the 21. 5.719 times 10 to the 21. And that is entities, all right? Entities. Another interruption, but not a problem. Let's keep going. So 5.719 times 10 to the 21 entities. Notice it's a big number. There's a lot of little molecules in there. And let's look at our significant digits. Remember, these don't count. 2 significant digits. This has 3 significant digits. Again, that's a 1. So I'm only going to keep 2 because I can only keep the least number of significant digits. That makes it 5.7. I look at the 1, that stays a 7, times 10 to the 21 entities. You could leave it as entities, but it is molecules of water. All right? So that's how you deal with the mole. All right? Hopefully this one's a little shorter. It looks like it says 16 minutes. Hopefully that's a little more bearable. Okay, I'm done, finally. No more interruptions.